we have completed the flip-flops. Now we will study the counters. So the first question that comes in our mind, what is a counter? What it does? So the counter is a sequential circuit and it just simply counts. If it is at 1, then the next time it will say 2, then 3, 4, and so on. Now the number from which it starts counting and also the number at which it ends the count depends upon your design. You can design your counter depending upon your need. For example, there may be a counter which counts from 0 to 10, and there may also be a counter which counts from 2 to 6. Similarly, there may be a counter which counts from 3 to 9. It all depends upon your design. So we know now what is counters and we have to see its working now. So let me rub this portion first and we will analyze this circuit that you can see here, that is having the JK flip-flop, and as you remember, the flip-flop is used to store the memory. But instead of storing the memory, it can also be used for the frequency division that you will just know in a minute. So let me write this thing down about this circuit. It is flip-flop as divide by 2 circuit. Why I am calling it divide by 2 circuit will be clear in a minute. There is a JK flip-flop, you can see, and another JK flip-flop is also, and the most important thing going in this 2 JK flip-flop is the clock is not the same. You are giving a clock here. Let's say the frequency of this clock is FC, but as you can see here, the same clock is not given to the second flip-flop, but we are giving the output of the first flip-flop as the input to the clock. So this is the most important thing in your counters, and what we are going to use here as the value of JA, KA, JB, KB is 1. So let me connect JA with JB, similarly KA with KB, and we will give the input 1 to J and K. Now definitely toggling is there, and I have repeated thousands of times when we were studying the JK flip-flops that we are going to use the toggling in counters. We don't use the race around condition. It is a not usable form. That's why we converted it by using the master slave operation or by negative edge triggered flip-flop. Here you can see this symbol represents that it is negative edge triggered. This bubble shows that it is negative and this arrow shows that it is edge. Therefore, in total, it is a negative edge triggered flip-flop. That's why we are overcoming the race around and we are having the toggling action. So this toggling is very important for your counters. So let's see how this circuit works, and I will say the frequency here as FA and the frequency here as FB. Now I have made the clock here, and we have to analyze what's going on depending upon the change of the clock, and as it is a negative edge triggered flip-flops, all the changes will occur on the falling edge when the clock is going from high to low. This is my clock, so all the changes will occur for this falling edge. Now, as I have already explained you, this clock is just given to the first flip-flop, whereas the output of this flip-flop is given as the clock to the next. So the changes that we will measure for this falling edge is only for the first flip-flop, and the output QA will be determined depending upon it. This QA then will be considered as the clock for our next flip-flop, and we will see how the frequency is changing. So let us try to find out QA. I am considering QA is 0 initially, so it is 0 till this falling edge, and as the toggling action is there, we are having the complement of the previous stored value. So the complement of 0 is definitely 1, so I am having QA high for this interval. Again we are having a change at this falling edge, and the 1 will become 0. Similarly, we can plot for the rest of the falling edges. Okay, Now the interesting thing will happen. This QA is now acting as the clock for our second flip-flop. So QB will not be considered depending upon this falling edges, but it will be considered depending upon this falling edges. This is acting as a clock for QB. So considering QB as low, so it will remain low till now, then it goes high because of toggling, and again at this falling edge it will become low. So this is what we got from this configuration. Now you can check for the frequency. Here the time period, this is my time period, let's say TC, and if I check for the time period of QA, and I will call it TA, so you can clearly see TA is twice of TC. And as you know about the relation between the time period and frequency, which is F is equal to 1 by T, I can write TA as 1 by FA equals to 2 by FC, or I can write FA equals to FC by 2. So FA is equal to FC by 2. Now the frequency is halved, that's why we call it as divide by 2 circuit. Now what happens to the frequency FC if we check here? So let's check for it. This is the time period TB, and TB is equal to twice of TA. You can see this is TA, and one more TA will fill up for TB. So 1 by FB is equal to twice of FA, or FB is equal to FA by 2, and writing it in terms of FC, I'm having FC by 4. So FB is equal to FC by 4. Frequency is now 1 by 4th. So again it is divided by 2. So if we are having in total P number of flip-flops in which the value of J is 1 and K is 1, and it is negative edge triggered, then in total we are going to divide the frequency by 2 to the power P. Okay, like in this case P was equal to 2, so 2 to the power 2 gives us 4, and frequency you can see is divided by 4. Similarly, if I am having 4 flip-flops, then 2 to the power 4 gives us 16. The frequency will be divided by 16. So this is the basic of counter. Till now it is not clear that how it is working as counter, but in a minute it will be clear to you that it is your counter. This is my counter, and it is counting from this particular circuit is counting from 0 to 3. So let's see how it is counting from 0 to 3. I have given the clock pulses numbers 0. This is my 0th clock pulse. This is my first clock pulse, then second, then third, and then fourth. I have given them the numbers starting from 0 because we only have to count the clock pulses and the counter will work. So how we are going to know which clock pulse is elapsed? It will be determined by the value of Q and QB. So let us first write down the clock pulses, and it is 0, 1, 2, 3. Then we are having our outputs QB, QA. So for this clock pulse, the 0th clock pulse, the QA is 0 and QB is also 0. So 0, 0. For the first clock pulse, the QA is having value 1, whereas QB is still 0. So 0, 1. For second clock pulse, QA is 0, whereas QB is 1. So 1, 0. And for this third, I am having QA 1 and QB 1 as well. So 1, 1. Now you might be thinking why I am not considering or calculating for the fourth pulse. I can show you. For the fourth pulse, QA is 0 as well as QB is 0. So again I am at this point and it will start counting 0, 1, 1, 0 and 1, 1. Then again it will become 0. So this is how this circuit is working as counter, and just by knowing the values of QB and QA you can know how many clock pulses is passed. 0 0 is 0, 0 1 is 1, 1 0 is 2, and 1 1 is 3. So by knowing this output, the output of my two flip-flops, I can know the clock pulses passed, and in this way the counter works. Similarly, you can make a counter that will count from 0 to 15. So how much flip-flop you require? You require 4 flip-flops. 2 to the power 4 gives you 16, and after 16 clock pulses, again the value of your outputs will become 0, and in that case we will be having 2 more outputs for the 2 more flip-flops, and we will check for that outputs. Let's say if they were QD, QC, QB and QA, and it will start from 0 0 0 0 all the way to 1 1 1 1, and by knowing these outputs we can know how many clock pulses has been elapsed. I will not explain anything more about this counter because it may be confusing to you right now. It's very hard to understand these things itself, so I will leave you with this thing. Please revise it. Please understand it. If you have any problem, you may ask in the comment section, and from the next presentation we will study more about the counters, and at the end you will find that you know the counters very well. As well, you can design any counter asked in the exam. We will also do some special types of counter in this course, so please watch the lectures and please remember what I have explained. So this is all. See you in the next one.